Good afternoon. Thank you all for joining me in this breakout session on coordinating dev and prod with SaltStack Formulas and DockerCompose. So, who am I? Good question. I'm Jason Thigpen. Sometimes I go by the pseudonym of CRD or something similar online. I enjoy riding motorcycles and writing tools in Go on the beach, in case you were interested. If I haven't had a chance to talk to any of you guys before now, hi. It's my sincere pleasure to do so. Thanks again for joining me. How'd I get here? So I'm currently employed by a company called Lucid. Lucid develops a product called Building OS. And there's a quote on the Lucid website saying that organizations use Lucid's Building OS data and analytics platform to optimize the performance of their buildings and teams. So it's energy management software as a service. If you were a user, you may get some dashboards like that about your energy usage. And they sent me here today, so thanks to them. Real quick thanks to one other person today. That person is Tedsky. He is the other operations member on our team, and he's currently taking my on-call rotation so that I can be here with you guys. So thanks, Tedsky. He's also the author of a really cool utility for managing LDAP credentials and SSH public keys. It's open source, and it's available at GitHub under the LucidDG namespace. So go check that out. It's really useful. We use it internally. All right, but why do you care? So I'm here to present a use case around how my colleagues and I have contributed to the community-maintained Docker formula. We use it to manage our containerized architecture with SaltStack. Surprise. Ultimately, we've added functionality to map Pilar data, which closely matches the DockerCompose specification, into salt states, which manage our Docker services and data volume containers. All right, so I'll start with some background into the situation that led us to the topic of this discussion. And then I'll go over the transitional phases that we outlined to get there. And finally, we can dig into the formula itself. All right, so anyone who's joined a team during a growth period is probably familiar with the pain of legacy infrastructure and technical debt, right? Decisions were probably made before you joined, and you weren't there to give your expert advice, so kind of a mess, right? So let's imagine for a second a very hypothetical scenario where you've inherited an infrastructure. That infrastructure is based on a golden image configuration management solution. That solution is probably about 90% complete. And even more so, it was written by someone who's no longer employed at the company, right? And now, you are tasked with DevOpsing the agile CI pipeline to continuously deliver hotfix releases every half hour, right? Easy peasy. So to be fair, though, and give credit where it was due, we do think that the design goals of our predecessors were largely in line with the direction that we've chosen today. Not largely different, it's just that they're not around anymore to maintain it, right? And we can rely on things like SaltStack and some others that have a large community that are constantly contributing to that solution. We did, however, set a moratorium on reinventing things which are otherwise well-maintained by a thriving community. You guys are here because you're a community of the SaltStack, so maybe you're familiar. All right, so we formulated a transition plan. Our main goal was that we wanted environments to match, right? So that changes everywhere, all the way from our local development environments, all the way up to production, we could have confidence that those changes were the same, right? We bumped Redis version in our local development environment. We're confident that nothing's going to break when it gets to production because everything matches. Now, in an effort to reduce the friction associated with such a large change, we broke that transition down into 3 phases from the ground up. We'll go over those a little bit. And whenever reasonable, not necessarily all the time, but when it made the most sense, our crack team of DevOps rockstars chose industry standard and community-maintained solutions rather than reinventing the wheel, right? So phase 1. Lowest level we cared about at the time is our operating system. The infrastructure that we inherited was already running Debian Wheezy in production, so we decided to standardize our development environments and everything in between on that. You may notice Debian Wheezy is not the current stable release. But in order to get a standard image to use from development all the way into production, we chose a tool from the Debian community. It's a community-maintained project called LiveBuild. And what LiveBuild does for us is it gets us a Debian Wheezy image with a kernel baked into it, which will support our decision to go with Docker in the future, okay? The kernel that shipped with Debian Wheezy isn't Docker compatible. No big deal, we just bake in one from backports, not a big deal at all. But now we've got an image, and to make use of that image, we chose a tool from HashiCorp. Maybe you guys are familiar with Packer. We use it to build Vagrant boxes and AWS AMIs. You could use it to build things on other infrastructure platforms as well, but those are the two that we cared about. All right, next up, configuration management. With our base operating system consistent across all environments, the next step was to consolidate the various ways of maintaining environment state into a singular interface, right? A standard and straightforward Django stack should be pretty easy to represent in a few simple states, maybe a little pillar data, maybe an extra formula. You could do this sort of thing over a few beers in an afternoon, right? No big deal. Why did we choose Salt? To us, at least at the highest level, Salt definition files are just really Jinja templated YAML documents. They ultimately become Python dictionaries. And in our experience, seasoned Python full stack engineers will quickly grok the layout of the SaltStack code base if for whatever reason they need more confidence that the changes that they're making to like our Salt states are what they're expecting to happen, at the back end. Lucid's obviously a Django shop, so the decision to choose Salt just fit really well with our culture and the experience that we already had. Phase 3, Linux containers. So we recognized pretty early on that the legacy infrastructure that we'd inherited could not support and sustain the business objectives of our employer. The Docker suite of tools provides all the features of our legacy infrastructure with some added conveniences, kind of helps us not shoot ourselves in the foot quite as easily. It's really not far off from what our predecessors had originally envisioned, but again, like this is a project that's maintained by other people. We're not in the business of container management software, right? So, now that our stack is fully represented in Salt states, it also became pretty clear like how to divvy out the work of migrating those Salt states, of managing package installations, sysvinit services running into Docker images and containers, right? We already have the place, here's our states, change them from being package management to managing Docker containers. In our local development environments, DockerCompose came in really handy. This provided us a really simple YAML interface for describing collections of Docker service containers, right? So I can say, I need a Django stack with Redis and Cassandra and a handful of other things all in a single document, DockerCompose up, really simple, right? Okay. So as we started managing those in Salt, our states look kind of like this. Can everybody see that okay? Yeah, okay, cool. So pretty straightforward, we include the Docker base, the base Docker formula, which gets us the Docker daemon running, the service running on the host. We have a Docker Compose formula that we contributed, which gets us all the prereqs for being able to use the Docker Compose command line utility. And then we just manage a file on disk from the Saltmaster file server. That's our Docker Compose file that you would use locally. And then on the host, all we do is Docker Compose up, pointed to that file, right? That's simple, but we also quickly realized how much of a divergence that was from the usual like standard Salt states that we would use elsewhere. We ultimately decided that the convenience and responsibility trade-offs just weren't enough for the limited flexibility of just saying like, throw this file on disk, DockerCompose up. And hopefully I can demonstrate later why that is. So we did, however, like we always said, well, like, man, that DockerCompose file, that's really convenient, right? It's just a YAML document where we can describe the containers we want and stand those up, right? It reminds us a lot like Pilar data. It's a YAML document that we use to drive the installation of things in formulas. So how do we make that happen? So we have a policy when we're creating new states that we want them to be somewhat formulaic, right? We want any new states that are created to be as flexible as possible. Like we want to be able to reuse them later. We don't want to have to like copy and paste this work over to another state, right? We want to be able to reuse this as easily as possible and also eventually maybe even contribute it upstream. So what we did was we encouraged everybody to write their own sets of states in the spirit of a formula driven by Pilar data. And so what we ended up with was, 7 different files that were similar but like subtly different in various ways, right? So, for Joe's collection of services, he's focusing on some data volume container. Jane didn't need any data volume containers, so she was solving a different problem. But what that allowed us to do is come back later on and compare all those changes and combine that into like a single, so like take the best of all of those, throw out the worst. And now what we ended up with was a consolidation of all that work into a cohesive set of tightly coupled states. We were able to submit that work to the community-maintained Docker formula, and today our states are really simple, right? We've got some Pilar data. It looks like DockerCompose file. We just include our DockerCompose formula there. All right, so quick show of hands who doesn't know what a formula, a salt formula is. Okay. Sounds like most people are familiar. The best way I can describe a salt formula is that they're tightly coupled states intended to provide like an overarching or higher level abstraction that you drive through Pilar data, okay? Hopefully the demonstration later can outline that a little better than my verbal description. So whenever my colleagues and I considered managing anything new with Salt, we always look for an existing formula first. So we found this formula on GitHub under the official SaltStack Formulas namespace. All right, sounds pretty legit. Let's go that direction, right? At the time of my first contribution, which was sometime last year, the Docker formula only offered functionality of managing a Docker daemon service. There was this extra piece that could manage a registry for you. It eventually became deprecated, and maybe I'll demonstrate why later. But this is what it looks like today. There's been a lot of activity. We use it, obviously we use it at Lucid pretty heavily. We're really happy with it. We think others seem to be pretty happy with it. It's up there. If there's any problems, file a bug, submit patches, whatever. It's all on GitHub. So when we first began managing the Docker service containers, like I said, we were using the DockerCompose command line utility. So we contributed this addition to the formula, which provided all the prerequisites for running that DockerCompose command line utility, right? Made sense for us. We need the stuff available. Maybe some others do too. As we moved away then from relying on the DockerCompose command line utility, we ended up with a new set of states, as I described earlier. They're clearly related, but with a slightly different objective, all right? We still felt that the DockerCompose states were useful. We still used them. We had really no visibility into who else might be using them. So rather than clobbering that, and because I'm embarrassingly unoriginal, we ended up just calling the states DockerCompose-ng. So -ng, new generation, like, if anybody's good at naming, feel free to have a whack at it. So who wants to watch a demonstration crash and burn? All right, that's what I thought. All right, let's see how we can do this. side. There you are. Oh boy, this is going to be fun. All right. So let's increase the font here. All right, cool. Rock on. Let's see, we go back over here. Okay, actually, let me quickly. All right, let's pull this over there too. So when we were in the process of contributing this back upstream, how do we make that work? Okay. Everybody see that okay? All right, so this is a document that I authored during the process of submitting our work back upstream to the DockerCompose community on GitHub. And the idea here was to compare standing up a Docker registry with the DockerCompose command line utility, and then compare the same thing using this new formula, right? Obviously, we want the output to be the same, just to demonstrate that our work fulfills the objective. Our objective, if it wasn't clear before, was to take that DockerCompose YAML specification and map that to be used with the Docker states. Right? Salt provides some native Docker states, Docker.running to make sure that your container is running, Docker.image, make sure that image is available, things like that, right? So we want to map that compose YAML document specification into Salt states. All right, so what we ended up with then is, if you guys want, I can pull over the Vagrant file. That might be useful. You see that okay? You want me to increase font? Increase. Let me know when. That's good. Okay. So they're all going to run a quick bootstrap. Pretty simple. We create a formulas directory, which, as far as I'm aware, is the convention for having formulas in a somewhat masterless setup. We install Git because we're going to pull the DockerCompose formula from Git. You'll notice here that we're pulling it from the LucidDG namespace on GitHub. This is sort of our convention for vendoring formulas that we use in production. So our Salt master uses GitFS to pull formulas from Git. And so we vendor that through our namespace on GitHub, so we can just when we're using formulas on Git, we're granting people with write access to that root access on our infrastructure, right? So this is one way that we use to prevent that. So the final thing that we do a salt call state.sls on that Docker formula, right? So all that does then is that just gets us the Docker daemon running and able to pull images and stuff like that, right? So the first thing we're going to do, we're going to run through the native setup, which is the DockerCompose command line utility. We can see real quick what that's going to do. I'll just switch back to the terminal here and show that off. Oops, that's the wrong place. Okay, so we'll have two Vagrant VMs available. I'll admit that I cheated a little bit and I set these up prior so that we don't have to wait for the internet to pull images and junk like that. Just kind of demonstrate what's going on. So we're going to spin up the DockerCompose VM real quick. And then once that's ready, we will show how we'll use the DockerCompose formula, which provides the DockerCompose command line utility and some Pilar data to install a DockerCompose version that we specify, right? So this sort of demonstrates the formularity of it. That's not really a word, but to use the formula, we drive it with Pilar data. Can everyone see the Pilar data there? Not really. Oh, there we go. Uh-oh, we're gone. Okay, so we're specifying the pillar on the command line as a Python dictionary. Is that clear to everybody? Okay, cool. Yay! Failures. Yep. Do as the super user. All right. That should finish pretty quickly because it's already in the right state, but this is just demonstrating, right? We specified the version as pillar data. You'll notice there DockerCompose version 1.5.2 got installed. And then really quickly, now what we'll do is use that DockerCompose command line utility to stand up a registry. Oops. Yeah, it's permissions again. All right, so that's running. Let's double check that it is. Is everyone familiar with the Docker command line? So we're just like listing that there are some services running. They're a few seconds old. And just to prove a little more, let's see if we can hit the registry with curl. So we'll notice Docker registry services running. Is everyone satisfied with that demonstration? All right, cool. Nothing special there. Let's turn him off now and get our next up. So this next one should be a little more interesting. I'm going to show you here with the, so here's how we stand up our Compose in G suite of registry service containers. We specified pillar by importing the YAML document from a file. Has everyone done that before? It's a kind of fun little way to pull pillar data in without like having to do actual pillar stuff, right? So we're just pulling it into the shell and again using it on the command line. Oh, man. All right, so here we are again. Yes, those are going to be two lines. The two lines that I just showed you where we pull in pillar data at the command line and then use it with our salt call. So does everybody see what's going on here? Oops. We do a salt call, state.sls, docker, compose ng, right? That's our formula that we're demonstrating, right? Oh, fuck. Who took these notes? They're fired. All right. So similarly, what you'll see now is that Salt has now handled the creating of our container and ensuring that it is running, okay? Like I said, I cheated. I made sure the image was there already, so it came quick. But, you know, so we're right here. We say that our container is installed and our service container is running, right? Again, we can do just a quick demonstration that that registry is running. And there it is. Cool. Everyone content with that? All right, if you're not, let me know. And go away again. Cool. So let's, basically what we did here, this document is outlining a lot of what I did. Automated it a little bit in the sense that just created a bash script that would run on both of those VMs when you vagrant up to catch the output, store it somewhere, and then compare it later. So what you'll see here is just a comparison between the output of both of those. The only difference are the unique IDs of the containers that were created, and then timestamps, that sort of thing, right? But otherwise, I did a quick inspect on the on the containers as well. Make sure that the data volumes were created, that sort of thing. So like I said, the link to this is in the presentation if you guys care to look at it anymore. It's there. We can now go back to the presentation. And all right, we got through that demonstration. All right. But why? Why would you do such a thing, right? DockerCompose already exists. But is anyone familiar with the Pilar namespace flattening and merging? Yes? Yeah? Okay. Well, we are. Obviously, we use it. So what we're doing here is we're taking advantage of a feature of Pilar where you can merge and or flatten conflicting keys. Okay? So in our case, we're doing that on purpose. That's from the Pilar documentation, that conflicting keys will be overwritten in a last one wins manner. Okay, and so we're taking advantage of that. What you'll see here is a contrived example of something similar to what we just stood up, which would be, this is a Jenkins example, I guess. But so what we have here is a base compose file in our Jenkins directory, and then we have production and staging. Right, so what we'll see next is that compose file, I call it Jenkins, but I actually used registry data, so pardon. But so this registry compose file actually looks a lot like the Docker Compose file that we used previously. The main difference you'll notice is that it lives under the Docker and then Compose namespace of our Pilar. That was the convention that we used in the formula. So ultimately what you would do then in the real world, and what we tend to do is we'll prototype with our Docker Compose YAML document, right? Once we prove locally that that works and we want to start moving that into production, we'll then take that document and stick it in Pilar data under the Docker Compose object, right? We have a data volume container here. You'll notice this is an attribute that doesn't exist in the, well, it didn't when we were using Docker Compose. It actually might today. They've been working on it. But what we decided was to just come up with a simple Boolean, DVC, data volume container. If it's true, this thing, we don't need docker.running states associated with this image, right? We just need to create the container itself, but it's not going to run because we're going to have a service container for that. But we do go ahead and set aside a volume so that we can, consider that persistent. We can back that up elsewhere. Then we have our service container. Same thing with the image. We'll create a container name. And so what you'll notice here is that in this case, in our base compose document, we specify an image of latest. So whatever the latest image available on the hub is at that time, we specify a container name, which has kind of a bogus 99999 nomenclature. That means something to us. It may not mean anything to you, but just notice that it's unique here. So now what we do, if we compare those production and staging files that we saw earlier, what we're doing is we're intentionally creating conflicting keys for image and container name. So let's look in staging. We decided we wanted to run a different version than just latest in staging, so we pinned it to 2.4. We also overwrite the container name. So let's say maybe 200 to us means staging and 01 is the first one available, right? Similarly, in production, we override the conflicting keys of image and container name, just a different image tag and a different name associated with that. Does everybody understand how you would use that to override the defaults? So you've got a default compose file that I can spin up in my local environment, works perfectly fine. When I push it out to production, that's the only thing that's different. Image names, image versions maybe. And obviously that's kind of a contrived example. You might have something more special, like you might have a different volume in production than you do. Like you mount things differently in different environments maybe. So this is just demonstrating our targeting. So our top.sls file, we're going to specify on this VM that we have the Jenkins compose, and then after that we have the Jenkins.staging, right? That's the last one wins part of the Pilar flattening, right? Same with this other VM. We're going to then target it with the production Pilar data last. And then some sample output, we just do a pilar.get, and then we traverse the namespace for the container name. And then you'll notice that on VM 200, the container name is registry 200. On VM 100, the registry name is registry 100. Cool. So you get why we would do that? Yeah? Okay. It wouldn't be fair to bring all this up if I didn't admit the caveats associated with this. So I mentioned earlier that we chose to make our environments match to improve confidence in changes between local development environments all the way through our production environments. We did this to work because our infrastructure required it, right? So our focus was on our current setup, so that's where all of our effort went. And at that time, the Docker.io execution and state modules were what was stable and available, right? We were running 2015.5 version of the Minion. Now there are newer versions available. There's a newer and more recommended Docker execution and state modules in the core Salt core available now. The work's in progress. My colleagues and I are continuously improving this. Other people in the community are improving on the existing formula. We've got more distros that are being supported every day. Newer versions of the Minion, which includes the newer execution and state modules. Again, Tedski has done a lot of work on this recently. That's largely because I'm sure you would all agree that your home infrastructure is vitally important. So there's no reason to run old versions of Minions at home because you don't have to. All right, so I've talked a lot. Who has questions? Crickets. Oh, sorry, I'm blind. Go ahead.
So you mentioned one of the reasons why you're doing this is because pillars can be merged. Is there any other reasons? Is that the only reason?
So, is it the only reason that we wrote the formula?
Yeah, rather than just using DockerCompose directly.
Right. So, yes and no. So, we really felt like using more native Salt execution modules and state modules was the right way to go because we're not always going to be in charge of an infrastructure as small as what we have today. And managing DockerCompose files on thousands of hosts, for instance, seems pretty silly. Not only that, but we may get to a point where we want to manage an abstraction even higher than that, right? Like we've got a cluster of things. DockerCompose can maybe do that today, but it's also the flexibility of just handing off all responsibility onto this other tool, right? And not only that, there's no real API available for DockerCompose, right? So we manage a file on disk, and then the rest of our interaction is DockerCompose up. We shell out to a command, and that's what we're relying on, right? So it felt like it made more sense to rely on the maintenance of state execution and states and execution modules built into Salt. Does that answer? Okay. Another question?
Are you using this with Swarm today, or do you know any reason why it wouldn't work with Swarm?
So we're not using it with Swarm today. Again, it's just, I have nothing against Swarm, but for us, it was a lot of this work was let's get this hodgepodge of environments as consistent as possible so that that we can make changes confidently, right? And so Salt and Docker and no more was like the fewest number of moving parts, right? So I think Swarm is cool. In the future, we may look at that, but not today.
So you want to move from chaos to order?
That's the plan, yeah.
Just don't understand entropy, do you?
Man, sometimes these sysadmins, they just want so much control, right? Any other questions? No? Okay. I hope this was enlightening. Is this an interesting thing to anyone here? Would anyone here find this formula useful in their work? Yeah? Okay, cool. That's good to know. Yeah, like I said, again, the caveats, we were Debian Wheezy with a custom kernel, like all of these things, so that was our focus. But since then, it's like, okay, now that that works and it's shipped, we can focus on making this more largely available. Actually, let's see if I can pull this up real quick. If we have a little time, I haven't really been following, do we?
We're at 15:23.
I actually don't even know. 5 minutes? Okay, cool. So, uh-oh, where's the mouse? Okay, so we should be able to go to the, rats. Let's go to GitHub Docker formula. Yeah, all right, that's where we are. Hey, look, Paul committed something recently. Good job, Paul. So you'll see here that there is also a docker.container piece of the Docker formula, which is which we are not using intentionally. But what happened here is that at the same time that we were developing docker.compose ng, someone else was developing in parallel a piece of the formula to manage containers also. What you'll notice when you start digging into this, however, is that they're doing something different. They're more like, they're shelling out a bunch to like make sure an image exists on disk, and they're managing specifically, I think it's systemd service files, right? So, I mean, that's another way to do it, and that's totally fine. It was simply that for us, using like the Docker native interface is what made the most sense. So these, they live in parallel. You can use either one. We chose to go this direction. And that's largely why they're named differently too, right? You can use either one. If you just want to, if you have, I think it was CoreOS that was the focus of this one. Don't quote me on that, I'm sorry, it's been a while. But yeah, so, and then you'll notice the Docker registry is deprecated because we don't need to anymore, right? Like I demonstrated how you can simply stand up a registry using the DockerCompose formula, right? Stand up a Docker registry with Docker, yo, or something, whatever that meme is. So yeah, feel free to dig in if you find that it doesn't do what you want it to do. So this is the interface for the that Docker container formula that I showed earlier. It's a little different. That's fine. Again, our focus was to take the DockerCompose YAML specification and work with that. We felt like that was a pretty nice interface, and we took what made sense and we added the DVC attribute because that's what we needed. The reason we add that, I don't know if anybody's familiar with the DockerCompose command line tool. At the time when we were using it, you could have a DockerCompose file that looked like this. It would simply try to run your data volume container. It just assumed everything was a service running, right? And so it would try to run it. So if you looked in Docker PS output, you would see like that's not running, and it sort of looked like a failure. So we just said that's fine. It doesn't need to run. Question?
Is the DVC the only one that you've added?
That's the only attribute that we added. Yep. There may be things that didn't matter to us that we left out, but we focused on everything. Like I said, when we let a bunch of people write their own stuff, we took all of those and we said, okay, like let's take everything that's important and focus on that, and we added the DVC attribute. Another thing that I'll admit to, that if you're a masochist and you look through the actual states definitions, it's a lot of Jinja, right? And we've heard a lot today, Jinja is not a programming language. So one major improvement would be to do a better job of that. But it's largely like, we're like, okay, well, we've got Pilar data, and we've got an interface to the, at the time, the Docker IO states module. How do we make those work? And so at the time, it was like, Jinja. If it's in Pilar, add the attribute to the state. And then mapping it too, right? Because it's not always one-to-one. So, question?
Does this work with newer versions of Docker? Like, my impression of Docker IO is that it stopped working like one or something.
Right, so Again, Tedski's working on that specifically because he's got a brand new infrastructure at home that he's managing. So if it doesn't today, it probably will tomorrow. So yeah. Anything else? Yes, question. So it depends on what day. So this weekend I was doing Gymkhana on the VFR. I've got a DR650 that I do, dual sporting on. I've got a SV650 that I crash on the track, I don't buy expensive bikes. Rock on. Cool. All right, if no more questions, you can have your time back. Thank you guys for joining me. I sincerely appreciate it.